Let's learn some of the techniques you can use for processing satellite data. We're going to work with Landsat 8 data. We have this folder called Landsat 8. We have provided you 5 bands from a Landsat scene. So we downloaded the data. When you download Landsat data, you have many bands. You get the spectral bands, band 1, band 4, band 5, 6, 7, 8. And you also get thermal bands. You also get QA bands, which contains cloud mask and so on. When you download the whole scene, each file comes separate GeoTIFF file. And for saving on the data space, we have just given you these files. So we have the red, green, and blue. So 4, 3, and 2. So this is the red, green, and blue band. This is the near infrared band information. And band 8 is the panchromatic band. So this is the data. You can see the panchromatic band has high resolution. It is 15 meters per pixel. All these bands are 30 meters per pixel. So we have this data that is given to you. Let's see how we can process and visualize this data. I just want to briefly show you a bit about the Landsat images. For folks who are not familiar with Landsat satellite image, we will link this in our notes so you can view this presentation if you need to. So Landsat 8 is a satellite that is a multispectral satellite. It's capturing the information in different wavelengths, and each data for each wavelength is saved as a separate file. This is the electromagnetic spectrum. The Landsat satellite captures information in the visible spectrum as well as the infrared spectrum. Here's a diagram showing where the different bands are. On the x-axis, we have the wavelengths in nanometer, and you have the bands here. So this is the Landsat 8 instrument. You can see it's got band 2, 3, 4. So this is the red, green, and blue bands. The 5 band is in the infrared channel. We have some of the shortwave infrared channels. These are the thermal channels. And you get different bands. So if you download the data, you will have an option to say which bands you want to download. You can download band 11 or 10 if you want thermal data. These are the bands which are for infrared and shortwave infrared bands. And these are the red, green, and blue bands. Interestingly, you have this band 8, which is called panchromatic band. Panchromatic means, pan means across, chromatic means visible spectrum. So panchromatic band captures information across the entire visible spectrum. So band 8 is similar to a black and white camera that you have. If you point that camera and capture the information, you get red, green, and blue light. All of those light is combined and you get the vision in black and white. So this is what panchromatic band does. Since it's a very wide band, you can see it has got more wavelengths to work with. So there's a higher amount of signal. So you can gather more signal and can get resolve differences much higher. It can resolve differences in a more efficient manner. So the signal to noise ratio is lower when you have a very wide spectrum. That's why when you have this red, green, and blue spectrum, those are lower resolution. You cannot resolve objects very clearly. So these are 30 meters, but when you have panchromatic band, it can resolve objects much better. So in case of Landsat 8, this is 15-meter resolution. So this is a higher resolution data. And one of the techniques you'll learn is how do we improve the resolution of this red, green, and blue channels by incorporating information from this band 8. So you can increase the resolution by using the information from the panchromatic band. Let's learn how to process this data and see and visualize this data. We'll start with section 1.4 on processing satellite imagery. Back in our terminal, we are in the NAPE folder. Let's exit out of this. We'll do cd double dot. And from the root data package, we'll do Landsat 8. Let's do ls or dir. And you can see we have those 5 GeoTIFF files. Let's see what these files look like. I'm going to open QGIS, and let's see what each of those files look like. If I load, say, the red channel information, this is a grayscale image. What the satellite is capturing is the reflectance of each pixel in that wavelength. So the pixel value, if I look at this, say 0.05. That means that pixel absorbed 95% of the light, reflected only 5%. This is the value between 0 and 1. This is the reflectance of the pixel in that wavelength. You can see clouds appear very bright because clouds reflect a lot of light. So you can see this is a very cloudy scene. I chose this scene for a reason. So you know how we can do some image processing to improve the quality of this image. But this is a scene over Assam, Northeast India. This is water body, and we have some cloudy scenes. We have some clear pixels as well. But you can see this is just one piece of information. If I look at the infrared channel, you can see this is what the infrared channel looks like. It's much brighter. The vegetation is all vegetation. Vegetation reflects a lot of the infrared light, so they appear brighter in the infrared channel. Water absorbs a lot of the infrared light. So in the infrared wavelength, this is what the scene looks like. Band 8 is the panchromatic channel. Once we can zoom in and see, you will see that this has got higher pixel resolution. You can see more finer detail. Now we have all this information. One of the first things you want to do is, what does this image look like to humans? How does it look like as RGB? So can we create an RGB composite? So if we take the red band and say, put it in the red channel, put the green band, put in the green channel, put the blue band in the blue channel, we get an RGB composite. So this is what an RGB image looks like. So this is what the scene would look like to humans if we saw it. So let's combine all of this and create an RGB composite.